Okay, my friends, I wanted to record how I would balance a chemical reaction like this. I've got aqueous phosphoric acid that's reacting with aqueous calcium hydroxide, and that is forming solid calcium phosphate and water. They're asking us to write a balanced chemical formula for this reaction. Well, our first part is we have to actually balance the compounds themselves. So phosphoric acid is sorry, my goofy board, H3PO4. That's something you'd have to look up. Phosphoric acid being the phosphate ion, which is a 3- that has 3 of these acidic hydrogens in front of it. We'll learn more about that in the future. Aqueous calcium hydroxide. Calcium is a 2+. Hydroxide is a 1- polyatomic ion. So you can see right away that I'm going to need 2 of these guys, 2 hydroxides to balance that 1 calcium. On the product side, we have solid calcium phosphate. So again, calcium is a 2+, phosphate is a PO4 3-, and I need to balance these guys. So my 6+ and 6-, that's going to be my balance point. So that means I need 3 of these and 2 of those. So, of course, there would not actually be charges in this compound, so I'm going to erase that just so you don't get confused. That here is my formula, Ca3PO4 2. So those are my pieces. And of course, water you know is H2O. So let's put this into our formula piece. Of course, this aqueous thing, the aqueous, that is telling me that it is a phosphoric acid that's dissolved in water. That's what this aqueous means. And it's calcium hydroxide dissolved in water. So here's what your textbook calls a skeleton equation. That I have my phosphoric acid plus my calcium hydroxide produces calcium phosphate plus water. And what I'm going to do here is I'm going to actually count the number of atoms that are present in this compound, both the reactants and the products. So let's start on the reactant side. Notice I have 3 H's here and 2 H's there because it's 2 times 1. So that tells me that I have a total of 5 hydrogens. I only have 1 phosphorus, so 1 goes there. My oxygens, I have 4 here, and I have 2 times 1 there, so that gives me 2. So 2 plus 4 gives me 6 oxygens. And I have only 1 calcium, so therefore I have 1 there. Let's do the same thing on the reactant side. My H's, I've only got 2. Those are over here. My P's, I have 2 times 1. So I have 2 P's. My O's, I have 2 times 4, plus this one over here. So that's going to give me 9 O's. And I have these 3 calciums. So 3 goes there. So you can tell right away, whew, this is a problem. Nothing is equal just starting off here. So what I have to do is add some coefficients to this thing. Now normally I tell you just start from the top here at hydrogen and work your way down. But the trouble is these H's, there's no number I can put here that's going to balance out this 5 and this 2. There's just not. I can't use 2.5. That's what I want, but I can't do that. So therefore, I'm going to skip the hydrogens to begin with. I'm going to go on to my phosphoruses. So I have 1 on my reactants, 2 on my products. So I'm going to put a 2 here. That's going to give me 2 of those phosphoruses, but it also affects my H's and O's. So 2 times 3 gives me 6. And again, here's my 2 times 1 gives me 2. 6 plus 2 gives me 8 H's. And my O's, 2 times 4 is 8. And 2 times 1 is 2. 8 plus 2 gives me 10 O's. Okay. My phosphoruses are happy now. Let's ignore the oxygens here. Let's skip down to calciums. Can we balance those? I think we can pretty easily by just putting a 3 here. So that's going to change this to be 3, which balances out with my reactants. But then my O's and my H's are affected again, right? Because this 3 goes with these guys as well. So let's count them up again. I've got 3, we'll start with the H's. I've got 3 times 2, because this is 2 times 1, right? So that will give me 6 here. And for my H's on this side, 3 times 2 give me 6. 6 plus 6 is going to give me a total of 12 H's on my reactant side. I go to my oxygens. 3 times 2, right, because this is 2 times 1. So that's 2 times 3 gives me 6. My oxygens, I have 4 times 2. That gives me 8. 8 plus 6, of course, is, uh-oh, push the wrong button. Oh, what in the world did I do? My apologies. There we go. Now I'm back. Talking about our oxygens here, I have 8 plus 6. That gives me a total of 14 O's that are on that reactant side. Okay. So now, are you comfortable that my P's and my CA's are happy? On my reactant side, this is the only term that has calciums and phosphates in it. So I'm going to try not to address that at all. I'm not going to try and put any coefficients there if I can help it. So let's see. If I look at the water over here, is there a coefficient I can put in that will balance out my H's and my O's? And if you think about it, 6 is the answer. Let me get rid of that line just so it doesn't confuse you. 6. So let's try it. 2 times 6, of course, that gives me 12. That balances out the H's. My O's, I've got 1 times 6, so that'll be 6 here. And I have 2 times 4, that will be 8. So 8 plus 6, when I add them together, of course, gives me 14. 12, 12, 2, 2, 14, 14, 3, and 3. So therefore, my formula for this is I need 2 phosphoric acids with 3 calcium hydroxides to produce 1 calcium phosphate and 6 molecules of water. Hope that's helpful for you.